I did answer letter A already, but hopefully you guys will be able to figure out letter A on your own. But let's move on and let's do another one. The next one I'm going to do is I think I'm going to jump down and do letter C. Let's do letter C, okay? So I'm skipping over letter B. So hopefully you can do letter B. I think you can probably figure that one out. I want to go on to letter C though. Letter C is iron bromide, or FeBr3 plus H2SO4, which by the way is sulfuric acid. That is a bad acid right there. And then it's going to make on the other side iron sulfide, which is going to be Fe2SO4 3 plus HBr. I don't know. Can you guys see that? HBr? Ooh, that's about out of there. What if I do this? Okay, now you can see it. All right, so we've got iron bromide is going to react with sulfuric acid. And when it does, it's going to make iron sulfide and hydrogen bromide. Okay, those are the things that we're going to make. How in the world can I get that to? Okay, it's kind of crooked, but hopefully you guys can see it okay. Maybe if I arrange it. There we go. That's better. Okay, so now we need to take attendance. And I'm going to show you guys a little hack here to kind of make this easier. But let's go ahead and get through this. So we've got iron, which is Fe. We've got bromine, which is Br. We've got hydrogen, H. And then, do you guys see this thing? This is what we call a polyatomic ion, this SO4. And you see we've got SO4 on both sides. When I see this on both sides, I'm going to just keep it like that. And I'm going to just keep track of it that way. It's just easier instead of breaking out the sulfur and the oxygen. So I'm going to write SO4 in here like that. Okay. I know that's kind of a weird thing. We didn't get to spend a lot of time on polyatomic ions. We normally would, but basically when you see things like that that are in parentheses and they're on both sides, then we're going to keep them that way. Okay. So how many irons did we start out with? Looks like we have 1. How many do we have afterwards? 2. How many bromines did we start out with? 3. How many bromines did we end with? 1. How many hydrogens did we start with? 2. How many did we end with? 1. How many sulfates did we end or start with? You see this whole thing? There's a subscript of 1 on the outside of it, right? So I have 1 over here. And how many do I have over here? I have a 3. Okay, so we have 3 on that side. Okay, so we're going to have to balance all these things out. And we're going to wait on the hydrogens. We'll balance them last, but let's do some of these others. How about if we go ahead and balance our irons? Okay, so I'm just going to start at the top of the list and move down, see if that helps us out. So on the iron, I'm going to put a 2 right here. And if I put a 2 there, remember that's going to be 2 times that whole quantity. So now I have 2 irons, but what else do I have? Mark that out. I have a 2. How many bromines do I have now? 2 times 3. Now I have 6 bromines. Okay, 2 times 3, I've got 6 bromines. So now the next thing I'm going to do is I'm going to come over here and let's balance those bromines. Here we have 6 and here we have 1. So if I put a coefficient of 6 right here, that's going to be 6 times this whole quantity, right? And if that's 6 times that whole quantity, how many hydrogens do I have now? I want to end up with 6. And how many bromines do I have? I want to have 6. Okay, so now my irons are done, my bromines are done. My hydrogen is not done yet, is it? But how can I balance my hydrogens? I've got 6 here and I've got 2 here. What if I put a 3 right here? That's going to be 3 times this whole quantity. Okay, so now 3 times 2 gives me 6 hydrogens, and it gives me how many sulfates? It gives me 3 sulfates. Okay, it's not going to be 3 times 4. It's going to be 3 times the SO4 times the whole thing. So I get 3 of these sulfate packages right here. And if that's the case, guess what? It balanced, didn't it? Ta-da! It's all balanced. There it is. The good thing about doing these balancing equations and getting them done, like if you know that it's done right, it's awesome, because what'll happen is they'll all work out for you in the end. So you can kind of start at the top, and then the rest of them just kind of like get in line, and it's pretty nice. Okay, so we used a coefficient of 2 and of 3, and this stays a 1, and then this was a 6. Okay, ready for some more? I'm going to do some of the hardest ones that you'll ever see, and that would be combustion reaction balancing equation. So we're going to do that one next, which is going to be letter D. So I'm going to do the next one down, which is letter D. Okay. So on letter D, we have C4H6O3. So this is a hydrocarbon. It's going to react with water. So we're going to add a water to it, or H2O. And when we do, we're going to end up with C2H4O2. Okay? So kind of a strange equation here. So let's try to figure this out. Let's go ahead and just take attendance. We've got carbon, we have hydrogen, we have oxygen. And that's what we have on this side too, carbon, hydrogen, oxygen. So how many carbons do we have to begin with? 4. How many do we end up with? 2. How many hydrogens do we have? And be careful, this is a trick question. I have 6 here, but what else do I have? I have 2 here. So that gives me 8 total. And then how many oxygens do I have? Again, it's a trick question, be careful. I have 3 here and I have 1 there. So I end up with 4 on this side. On this side, how many hydrogens do I have? 4. And how many oxygens do I have? 2. Okay, so it looks pretty simple straight up, right? Well, let's go see what we can do here. We have a 4, 8, and a 4, and we have a 2, 4, and a 2. Can you think of any coefficient that I could put right here that would balance everything in one fell swoop? I can. What if I put a 2 here? If I put a 2 there, that's going to be 2 times 2. That gives me 4. 2 times 4 gives me 8. And 2 times 2 gives me 4. Okay? And there it is, balanced. Got it done. Okay, so I've done 3 of them so far. I'm going to do a couple more, and then we're going to kind of set you guys loose, and you get to do some on your own. So I'll erase this, and we'll move on to one that's like way harder, right? We want some that's, come on, Miss Bowman, you do the hard ones. That one was stupid easy. All right, let's jump all the way down. I see one that's really hard. Let's look at letter F. Do I want to do F or do I want to do G? How about let's do F and then we'll do G. We'll just do both of them, okay? So letter F is going to be C4H10O plus O2 yields CO2 plus H2O. Okay, so here we have, this is called a straight up combustion reaction. We're going to burn this in the presence of oxygen, and we're going to make carbon dioxide and water. Okay, so that's the equation. Now let's go ahead and balance it. What do we have here? We have C's, we have H's, and we have O's, right? And then C, H, and O's, same thing. How many carbons? 4. How many carbons? 1. How many hydrogens? 10. How many hydrogens? 2. How many oxygens? 3. How many oxygens? 3. Okay. So here we go. We got to try to figure this out. And this one's going to be a little harder than you think. Okay. But let's go ahead and try to get into it. Probably what we want to do first is try to balance our carbons, right? So since it's the top of the list, and since we always balance oxygen last, you always try to wait on it, and a lot of times it'll kind of balance itself if you leave it alone for a little while. We're going to balance our carbons first. So to do that, I'm going to have to put a 4 right here. If I put a 4 there, that's going to be 4 times that whole quantity, right? So now 4 times the carbon gives me 4. 4 times 2 gives me 8 oxygens plus another one there. That gives me 9 oxygens total. Okay, 4 times 2 is 8. There's 8 oxygens plus there's another oxygen over here that I have to keep track of. So that gives me 9. Okay, so we got our carbons balanced. Let's try to go for our hydrogens next, okay? So for the hydrogens, we've got 10 on this side and 2 on that side. What if I put a 5 here? If I put a 5 there, that's going to be 5 times this whole quantity. 5 times 2 gives me 10 hydrogens. But it also gives me how many oxygens? It gives me 5. So now let's add up all of our oxygens. I've got 5 of them here, okay? And I have 4 times 2. I've got 8 of them there. So 8 plus 5, what's that going to be? That's going to be up to 13, right? Or is it 8, 9, 10, 11, 12? Yeah, 13. I doubt myself. So there's 13. How was this going to work out? Did I add that up right? Or is it 8, 9, 10, 11, 12, 13? Yeah. There's 8. And there's 13. Okay. So we've got 13 over here. I don't know why I'm not understanding that. Okay, so how many are going to be over here? I've got 3 over here. Uh-oh. How am I going to go from 3 to 13? Well, let's come up here and look. I've got 1 there. So if that's 1, then I need 12 more, right? Well, what can I multiply here to make this 12? Oh, that's pretty easy. What if I put a 6 here? If I put a 6 there, that's going to be 6 times 2, which is 12, plus another one, which is 13. And there it is. I got it. It's balanced. So I end up with a coefficient here of 1, here of 6, here of 4, and here of 5. And that's a balanced equation. Okay, so I'm going to do the next one. I think these hydrocarbon ones are actually some of the hardest ones you'll ever do. So I want to make sure that I try to do those for you. Save you the agony a little bit there, at least when we're just getting started. So the next one I'm going to do is G, letter G. So I'm kind of jumping down to that one. This one's going to be C7H16 plus O2. And it's going to make the same thing again, CO2 plus H2O. Okay, so this is, again, we have a hydrocarbon burning in the presence of oxygen, and it's going to make carbon dioxide and water. That's what it makes. So let's see. We've got our attendants again. We've got C's, we've got H's, and we've got O's. How many carbons do we begin with? 7. How many do we end with? 1. Hydrogens, 16. Over here, how many hydrogens? 2. Oxygens, 2. Over here, 1, 2, 3. Okay. So now what we're going to have to do is try to figure out how to balance this one. Again, wait on your oxygens. Don't balance those until the very end. Start with the kind of carbon first, probably. So we've got 7 carbons here. So what am I going to do here? If I put a 7 there, that's going to be 7 times this whole quantity. So that gives me 7 carbons. What else does it give me? 7 times 2, it gives me 14 plus another gives me 15. Oh, whoa, 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 whoa. Not there. Sorry. Leave that 2 there. It gives me 15 oxygens. So 7 times 2 is 14 plus another one is 15. There's my 15. Okay, sorry about that. Didn't mean to put that on the hydrogen. The next thing I'm going to balance is my hydrogen. I've got 16 over here and I've got 2 over there. What if I put an 8 here? If I put an 8 there, that's going to be 8 times this whole quantity, right? So 8 times 2 gives me 16. Awesome. But what does it do to my oxygens? It gives me 8 oxygens here. There's 8 plus how many were here? 14. There were 14 there. So that's going to give me a total of 20, right? That gives me 22. That gives me 22 oxygens on this side. So change that to a 22. Can I come over here and make this a 22? Yeah. What would I put here times 2 to make this a 22? So what times 2 is 22? That's going to be an 11. Yeah, these numbers are getting big, aren't they? So 11 times 2 is going to be 22. And now it's balanced. So I have a coefficient of 1, a coefficient of 11, a coefficient of 7, and a coefficient of 8. All done. Okay, so let's do this. If someone would like, we'll do a little bonus round here. If someone would like to jump in and tell me another number that they want me to work, I will work one more for you.
J.
What number? J?
J.
Okay, so we're going to move down to letter J. And letter J is, and that's a good one to choose, by the way, C7H9 plus HNO3. HNO3 is nitric acid. That's probably the scariest acid that I know. It's a super dangerous acid. So we're going to have some hydrocarbon with some nitric acid. And what's it going to make? It's going to make C7H6NO2, NO2, and it's going to be 3 of them, plus some H2O. Yeah, this is a great one to choose. I'm glad you chose it because it's a hard one. Okay, well, let's take attendance. Here we go. First of all, do I have any polyatomic ions? I see that I have a parenthesis here. This is a polyatomic ion at NO2. Do I see an NO2 over here? I do not. So I'm going to have to break everything out, okay? So we're going to go C, H, and there's more H. There's going to be an N, and there's going to be an O. C, H, N, O. Okay, so that works. How many carbons? 7 over here. 7. Okay. How many hydrogens? I've got 9 here and another one there. That gives me 10. Okay, let's come over to this one. I've got 6 here and I've got 2 there. So that gives me 8. I have 8 over there. Here, yeah, I did that one. Nitrogen, I have 1. Nitrogen up here, I have, do you see that this 3 is outside this parentheses? When you see a 3 like low like this outside of a parentheses, that's going to be 3 times everything inside that quantity right there. Okay, so that's going to be 3 nitrogens in there. And what else does it have in there? That's going to be a 3 times 2. That gives me 6 oxygens in there. 6 oxygens plus another one gives me 7 oxygens here. And on this side, I have 3. Okay, well, where should we start on this one? Well, when I look at it, maybe we should go ahead and try to balance our hydrogens, okay? Clearly, our hydrogens aren't balanced yet. Our carbons are. That looks pretty good. But these are not. So let's try to balance these guys out. I've got 10 over here, and I've got 8 over there. I know I'm going to have to probably multiply this guy by something, right, in order to get it to go a little higher. What if there's 6? What if I do this? What if I put a 3 here? If I put a 3 there, just stay with me here for a second. This is a little intuition here. 3 times 2 is 6, plus another 6 gives me 12. So that gives me 12 hydrogens. And then it gives me 3 oxygens here, plus another 6 oxygens there. That makes that a 9. Okay, just bear with me here for a minute. And now I'm going to come over here to this side. And if I put, what should I put here? How about if I put a 3 here? if I put a 3 there, that's going to be 3 times this whole quantity, right? So that gives me 3 hydrogens here, plus another 9 there. Hey, that's 12, isn't it? Okay, so that gives me 12 hydrogens. How many nitrogens do I have now? 3, right? 3 times the nitrogens. And how many oxygens do I have here? That's going to be 3 times 3, which gives me how many? Gives me 9. Ha! Is it balanced? 7, 12, 3, 9. Done. I love it when it works out easy like that. So I put a coefficient of 1 there, 3 there, 1 there, and a 3 there. And it's balanced. What do you think? Should I do one more for you? Call it a day? By the way, this is super nerdy. Balancing these equations can actually secretly be really fun, especially when they work out like magic like that. Anybody have one more for me to do? I'll do one more. Speak now or forever do them yourself. Everybody good? Well, if you're good, then you're free to finish them up yourself and go ahead and get them turned in. And yeah, there we go. So that's the assignment for today. Please make sure that you do the Ed puzzles. I want to make sure that you watch those. Again, they're just going to walk you through them, walk you through them, walk you through them. Okay. All right. Well, if we're good, then I'm going to stop recording